Okay, I'm doing this video because I have a friend that asked me to work on this Worx power tool battery. The charger is saying that the battery is dead or defective. I just plugged it in and it actually shows that it's actually green, like there's nothing on the charger, like it's ready to charge. So let me slide this back in again. Alright, so it shows it being a solid red, so that means it's not charging, and the little thing says it's defective. So I'm gonna go ahead and try to see what's wrong. This Worx power tool is an 18-volt battery, so I'm going to go check with my voltmeter to see what the voltage is on the battery. It says it's 18.8 volts, so I have to go in this a little bit deeper just to see what it may be. So they use torque security bits. I think it's T10. Alright, well, that came apart easy. Nothing remarkable on the bottom, just a little mesh screen. It looks like a metal mesh screen melted into the plastic down there. So here we have this. It has a 60 amp fuse in it. It looks like almost like one of those audio mini A&Ls, and I'm looking at this. I'm trying to find if there's any BMS circuitry, but from this angle it looks like there's nothing. It looks like 1, 2, 3. It's a 5S pack. 5S isn't supposed to be 18.8 fully charged. Let's see what it actually is supposed to be. So 4.2 is the fully charged voltage times 5. It's supposed to be 21 volts. So I'm reading 18.8. So let's see, 18.8 divided by 5. 3.76. So if the cells shouldn't be depleted, I'm just kind of wiggling this out. Alright, so there is a BMS on here. There's like a current sensing shunt, a few bleeder resistors. Well, I can't say that there's bleeder resistors. BMS sits on top of 2 posts right here, and so just lifting it to see what type of sense circuitry that there might be. I see 2 thermistors for the battery pack. There's one right here, and then there's is that another one? I know there's definitely a thermistor that'll gauge the wires. There's a 2-wire thing, and it's got some gloop on the cell. Just peel some of this back a little bit. You would think they'll be detecting the balance of the cells somehow. Give me 1 minute while I break this down. Okay, so I peeled everything apart. Still have the BMS up here, and we do have sense wires there. Let's see. Okay, the positive starts right here, and the positive goes straight to the BMS input or output, however you want to look at it. And so if this is the positive, then that's the negative of the first cell, and then we have a sense wire right here, then go straight over and it's the positive of that cell, and so it just kind of zigzags back and through. So now I'm going to check the voltages of all the cells to make sure they're all in balance. So we have 18.8, which is the full pack voltage. I'm also going to verify and check it on the actual sides of the cell. 18.79. Alright, so checking the first cell. Here we go. 3.48 is the voltage of the first cell. 3.67 is the voltage of the second cell. 3.77 is the voltage of the third cell. 3.85 is the voltage of the fourth cell. Fifth cell is 3.97. So this pack is way out of balance. So what I'm going to do is I'm going to solder some, I got a balance cable here. I'm going to solder some connections on the cells and hook it up to my charger and try to balance this pack. Alright, so I don't have a 5S connector, I have a 6S hobby connector, and so what I'm going to do, I'm going to take this out of the package, cut the female end off, and then start soldering them directly to the tab of the cell, so when I plug it up to my charger, I can start balancing the pack. Alright, give me a second while I get to work on this, and I'll show how it looks like when I'm finished. I soldered all the wires onto the BMS. This is a 5P pack, but this is a 6P plug. So all of the cells are being tapped off and going to this balance tap. Now I'm going to get my iCharger. I'm going to plug this in the balance port of the iCharger. And then I'm going to use some alligator clips to clip right here and clip right here. And then we're going to put the battery, we're going to balance the battery and then charge it. Okay, so I just finished charging up the battery, and everything was 4.2 across the board, and the first thing I noticed was the first 3 cells started to drop, so I'm assuming that the BMS is drawing off the first 3 cells. I mean, it could be a surface charge or whatever, but it seems like the first 3 cells dropped significantly versus the other cells in the pack. But either way, the pack is back in balance. The lowest cell was like 3.4, the highest cell was 3.9, and to get everything back in balance and charged, I put about 1,067 milliamp hours back into the pack, and the pack is a 1,300 milliamp hour pack, so it was way out of balance, but it should be a lot tighter than it was before. So I'm going to disconnect all this stuff and put it back together and put it back on the charger to see if the charger recognizes it. Okay, so I got all the sense wires off and everything. I was just looking at the pack here and the casing and everything. There's really nothing metal in here. I think the padding that was on the side of the seal was just for kind of making a snugger fit. I will still try to, you know, put some tape on it, so I'm gonna go ahead and do that right now. Okay, so I have tape covering the exposed connectors and everything, so I'm ready to set this back back in its case. So I'm just looking at how everything went back in. This is where all of this goes back in, so just flip this over and it sets in like so. Alright, put the case back on. And put the screws back in. Alright, so this has been properly refurbished. Let's put it back in the charger. Still showing defective battery. That is very odd. Okay, I really can't tell if this battery is ready to go or if it's charging on the charger. One of the things is because I fully charged this battery, so it may be that I'm putting it on the charger and it's sensing that it's already charged, like it charges for a few seconds. Or it's either, like I said, it's either this label is really stupid. It's either saying that it's charging for a few seconds and then that it's done charging, or it's saying that the battery is defective. I would assume that if the battery is defective that it would stay red, but it's doing the same thing that it was doing before, where it will show red and then after a few seconds it will go back to green. So what I'm going to do is to knock some of the charge off this battery. I'm going to disassemble it, put it on my load bank for like 10-15 seconds, which should hit the battery pretty hard, and then check the voltage and then see if it's low enough for the BMS to kick in. Because one thing, the BMS might not be fully charging these batteries. They might not charge it 4.2, so it thinks that it's an over voltage, so it disables the charger from charging it because the cells are too high. So again, I'm going to take it apart, knock some of the charge off and put it back on here, see if it recognizes it and if it will start charging. So I'm set this aside, take this apart again. Alright, got it apart. Okay, let me put this back in here. There we go. And then that spring goes right there. I know that this is negative over here and positive over here, so I'm gonna bypass the BMS. There's a 60 amp fuse. I know my low resistors don't pull more than 45 amps, so I should be able to put the electrode right here and drain the cells for a few seconds and get the voltage down, and then put it back on the charger to see if it will charge. Okay, I got my load resistor, so it's the same one I used to test my 12 volt power supplies. It's just nothing but a half ohm resistor. So let's go ahead and see if I can load this thing down to drain something. The polarity doesn't matter with this resistor. So I got one there and one here. Just kind of pulsing the cell a little bit. It is making a connection. I'm seeing a little spark. Alright, that should be enough to get it to drop down a little bit. Cells feel quite warm, because like I said, that load should have been discharging about 40 some odd amps. Alright, so I charged this up to 4.2 volts a cell, and the voltage should have been, let's see, 4.2 times 5 should have been right around 21 volts. So I hope that I dragged it down enough to get it to activate. So I'm just getting my voltmeter back out. Sorry, this is not in frame very well. Alright, so just checking it with the voltmeter. It's at 2025, 21 volts is fully charged. 2023, 2027. So it actually might be rebounding a little bit. So let me get the charger back out. I'm gonna see if I can plug this into the charger without actually putting the case and everything back on. So we got the charger right here. And those cells are quite warm. But like again, it has a 60 amp fuse. So go ahead and slide that back on. Alright, so I think it's charging. The solid red light is battery charging. So I knocked off enough for it to start charging again. So I'm thinking once I put it, like before, it was letting you know that the battery was defective when I put it on the charge before, when I first got it. But after I charged it, it was fully charged, so I didn't see any reason for it to charge. So it went red like it was charged, and it went back to green, letting you know that the power was on and the battery is charged. Yeah, I knocked some of the surface charge off of the battery and put it back on the charger, so now it seems to be holding red, indicating that the battery is charging. So I'm gonna let it sit here for a few minutes and let it charge back up, and we'll see what this charger actually charges these batteries to. So I'll come back in a few minutes. Okay, so I put it on the charger and it stayed red for a little while, so that means it was charging, and then it automatically went to a solid green, so that means it's fully charged now. So I'm gonna take it off the charger just to see if I put it back on the charger, will it go red and then go back to green, and then that'll let me know that, you know, it was fully charged or whatever. So I'm gonna just take it off the battery. I'm gonna take it off the charger. Okay, so that green, solid green, is supposed to mean that it's powered on and battery is charged. Let's see if we can get this back on there right. Alright, so it went red. I should go back to green. A solid red mean, oh, there we go. So it topped it off. and it's fully charged. So I'm going to take this off the charger, and I'm going to, I know this pack is balanced, so I'm going to check the overall voltage of the pack just to see what it's charging it to. So I got my meter. So DC. Alright. So I know negative is over here and positive is down here. So 2057 is the full charge voltage that it charged up to. So 2057 divided by 5. It's charging these cells up to 4.11 volts a cell. So that's quite conservative. So, but I think the pack is finally successfully recovered. I couldn't tell before, it kept on kicking it back as a bad battery. But, you know, draining it a little bit and putting it back on the charger and letting it charge back up to what it wants the full voltage to be. And like I said, that's 4.11 volts a cell. So I think the pack is successfully recovered. It's charging properly and everything. So I think that was a good investigation. On to the next.